Our first construction is constructing a copy of a segment. So we're going to start with a ray. I'm going to measure the segment that I'm given using my compass, so putting my end point at one end and dragging the other end to the other end point. And then I'm going to drag that down to the end point of my ray and swing an arc that intersects the ray that will give me a congruent length. So now I've got two congruent segments looking from endpoint to endpoint. Our second construction is bisecting a segment. So I'm going to put my compass at one endpoint, open it more than half the length, and I'm going to swing an arc on one side and then move it to the other side and swing an arc below. You could also do a full semicircle here if you wanted. Then I'm going to move my compass to the other endpoint without changing the distance that it's open, swing an arc above again, and then swing my compass down and swing an arc below. And again, you could do a full semicircle here. That will give you two intersection points, and then use a straight edge to connect those, and that will give you the perpendicular bisector. Now that point where they intersect is also the midpoint, so this is also sometimes known as a midpoint construction. Now we're going to apply this two different ways. So we're going to construct a perpendicular through a given point, and we need to start by creating two endpoints for a segment that we can bisect. So I put my compass on the point on the line, and I draw a semicircle so that I get two endpoints. From those endpoints, I'm going to bisect that segment. So you can see I put my compass on one end, made sure it was open more than halfway, and then keeping open the same distance, I swung it to the other end. And I only need to do the arcs above, but I can do the ones below if I want to. And then I'm going to connect that point with the intersection point, and that will give me a perpendicular line through the point. The second application is if we want to construct a perpendicular through a point off the line. So again, I need to create a segment with endpoints. So putting my compass on that point, I'll swing an arc so that I get two endpoints. I'm going to put my compass on one of those endpoints, open it more than halfway, and then I'm going to swing an arc below my line in this case, move it to the other endpoint, and swing an arc from that point as well. That intersection point needs to be connected with the point that I originally started with, and that will create a perpendicular through the point off the line. Another way we can think about applying this is bisecting an angle. So I'm going to draw an arc to create two endpoints, and think about that like the endpoints of a segment, right? Now we've got these two endpoints. I'm going to put my compass on one of them, make sure it's open more than halfway, and swing an arc. Move the compass to the other endpoint, swing another arc, and then just connect that with the vertex of the angle that I started with, and that will give me the angle bisector. The next basic one that we learned this year was constructing congruent angles. So we're going to start by building the foundation of our angle, right? Whenever you build a house, you lay the foundation first. Then we're going to draw an arc because we want to be able to see how big this angle is, and we're going to repeat that on the angle, draw another arc. From there, we're going to use those two intersection points to measure how far open our angle is. So, using your compass, measure from one intersection point to the other. This might take a little adjusting. And then we're going to slide that down to the intersection point that we already have. So, taking that, sliding it down, and drawing another arc. That tells me exactly how far open I want my angle. And then I can use a ray and connect the end of my segment that I started with to that intersection point, and that will be a congruent. Another way we can apply this is by constructing parallel lines. So I'm going to construct an angle by drawing a transversal in, and then I'm going to draw an arc through that angle because I'm going to copy this angle up. So there's one arc. I'm going to slide it up to the point and draw another arc. And then I'm going to measure the width of that angle. So again, this might take a little adjusting, but measure from one intersection to the other. Slide that up to the top intersection point and draw another arc so you know they're open the same width. And then you can use your straight edge to connect those, and that will give you a perfectly parallel line that goes through that point. And all we really did was copy an angle. So here's some of the fear about the Regents, is that they could ask you any question in the whole wide world. And so how do we apply what we know? And that's what we're going to talk about next. One of the ways we've actually seen this asked most on the Regents is when they ask you about an altitude. And remember that an altitude is a perpendicular line that comes down from a point and needs to be perpendicular to the base. Maybe not necessarily through the base that we see, but still needs to be perpendicular. So on this triangle, I'm going to extend that base out so that I can construct a perpendicular. Take my compass, and I know perpendicular, so I need some endpoints. So I'm going to pull this down so it goes just past that segment, draw an arc so I get 2 endpoints, and then bisect that segment, right? So open more than halfway, do an arc below, and then flip it around to the other side, and do another arc below to get that intersection. So this would give me my construction of an altitude, and all it really is a construction of a perpendicular. So then use your straight edge to connect A through there. On last June's Regents, they asked this one directly, construct an altitude of a trapezoid. Same exact thing. I'm going to pick up vertex, come down from that, and draw my arc so that I get 2 intersection points, and then bisect that. So what you need to be asking yourself if you get a construction that you're not familiar with is, which construction that I already know how to do is this? Maybe altitude doesn't come to mind, but perpendicular should. And so if you think about your properties of geometry and the altitudes are just perpendicular lines through points, then constructing this becomes very simple. They could also ask something like construct an equilateral triangle. So I know I need 3 congruent segments. So I'm going to start by constructing one segment of given length, and then I know from that segment I need another one going the same length. So I just moved my arc. Then I'm going to flip over to my endpoint, without changing my compass, construct another segment of that length. And so all this is the copy a segment construction. So I've copied that segment 2 more times, and when I connect all of those, I get an equilateral triangle. So now for some even funkier segment copying. I want to construct 4AB minus CD. So I'm going to measure AB, and I'm going to construct 4 of them. So 1, 2, copy it again is 3, and copy it one more time will be 4. So that right there is 4AB, that length. Now I want to subtract out CD. Okay, so I have my 4AB. I want to subtract out CD. So I'm going to take my compass, measure the length of CD, and I'm going to need to subtract that out. So once I get that length, which again can take some maneuvering, we are going to take that and subtract it away from the 4AB that we already have. So starting with my compass at the end point, I'm going to draw an arc going backwards, because that would be removing CD. And what's left over there, that 1AB plus a little bit more, that is the length of 4AB plus CD. Some more applications, thinking about what we know about geometry. Given the diameter, find the center. Well, the center would need to be the midpoint of the diameter. So I'm going to bisect this diameter. So again, endpoint, and make sure it's open more than halfway. Swing an arc from one side without changing your compass length. Swing an arc from the other. Connect those, and that will give you a perpendicular bisector. The center of the circle then would be the point where those intersect. So not some other construction you need to remember. You just need to think which construction that I know is this. On the next one it says which is larger, AB or half of CD. Well, here's AB. I'm going to measure that. And I'm going to use this line down here to compare them. So there's AB. And now I want half of CD. So I'm going to bisect CD and make sure that this is open more than halfway. I'm changing colors just so it's easier to tell. And I'm going to switch that to the other side and do the same thing. Then I'm going to find my midpoint. So using a straight edge, I'm going to connect those. And I'm going to measure that length, because that length will be half of CD. So I'm going to measure that length from that endpoint to the midpoint. And then I'm going to compare these. So the red that I see is AB. Oops, we moved that off the screen. And I'm going to put this blue one down with the same starting point and see which one's longer. So that is closer to the start, which means that AB is my longer segment here. AB is the longer segment because that goes further from the starting point. Here's another one. So I know that CD is a third of GH, and I want to construct GH. So I'm measuring CD, and I know that that is 1/3 of GH. So starting at G, I'm going to say that's 1/3. Move it along, that would be 2/3. And move it along one more time, and that would be 3/3. So that point will be 3/3 of GH, or 1/2. So that point right there is H. So now I want to construct angle E prime such that the measure of E prime is double the measure of angle E. So I'm going to copy the measure of angle E, or copy angle E twice. So that is an arc. I drew it on angle E, and then I copied it down to E prime. And now I'm going to measure how far open angle E is. So from right there to right there, those 2 points. And instead of just copying that once down, I'm going to copy it down twice, right? Because I want an angle that's twice as big. So there's 1, and I want double the size, so there's 2. And then I can just connect those. So connect point E prime to that next point, and that will give me the angle that is double the size. Next up, we have our circle constructions, and these have been very popular on the Regents. So starting with an inscribed square, we're going to draw a diameter, and then we are going to bisect that diameter because we know a square will have 90-degree angles, it will have perpendicular diagonals, and it will have congruent diagonals. So I am drawing an arc from one side, making sure it's open more than halfway, drawing an arc from the other side, making sure my compass is open more than halfway. I am using a straight edge to connect those. And now I'm looking at the points where that line hits the circle. And where that line hits the circle, I'm just going to connect to my original diameter's endpoints. And that's going to create a square. There we go, a square inscribed in a circle. The next one is inscribing an equilateral triangle. So I'm going to put a mark on my edge so I can measure a radius. You could draw in the radius here if you wanted to. And measure the length of your radius, and we're going to draw arcs all the way around our circle that are that size. So we should be able to fit 5 of them in. So starting at our original mark, there's 1. Slide it to that point and draw an arc. There's 2. And continue that all the way around the circle. And so we're going to get 6 points, right? The 5 arcs and then our original point. And this is the same construction we'll do with a hexagon. So with an equilateral triangle, we are just going to connect every other point. With a hexagon, we're going to connect every point. So there are my arcs. Taking a straight edge for an equilateral triangle, we're going to connect every other. And for a hexagon, we would connect every one. So let's do this one more time. Put a mark. I'm going to draw my arcs around. And then I'm just going to connect each of those points with a straight edge. So 1 side, 2 sides, 3 sides, 4 sides, 5 sides, and 6 sides. There is my hexagon. Some of the most important constructions we did this year were constructing our rigid motions and our transformations. So we're going to start off here by constructing reflections. So I'm going to put endpoints or points in 2 places on my line, and I'm going to measure the distance from each point to the points in my pre-image. So from that first endpoint to B is that length. I'm going to flip that over my line of reflection and draw an arc. Now I'm going to measure from that same point to C, flip that over a line of reflection and draw an arc. And do the same to A, because remember that this reflection should preserve distance. Flip that over my line of reflection and draw an arc. Now I'm going to flip my compass down to my other endpoint that I put on there, and I'm going to repeat the same exact thing. So I'm going to start at A. That's the right length, so I'm going to flip it to the other side and draw an arc, and that will be where A prime is. Now I'm going to repeat for C. Measure that distance, flip over to the other side, and draw an arc. That will be where C prime is. Again, distance is preserved. Lastly, I'm going to go to B, and swing it to the other side, and that will tell me where B prime is. So now using a straight edge, I can connect those 3 points, and this is what my image will look like after reflection. And you want to label those with primes. So top one would be B prime, this one would be C prime, and the bottom one would be A prime. So now we're going to repeat this whole process for another one, and I want to look at one where the point of reflection is on the line. So looking at this one right here, you can see that point A is on the line. Since distance is preserved, since it's 0 distance from the line, it will stay there. So I'm going to put my 2 points on there, and the only points I need to reflect are B and C. So I'm going to repeat that process. So starting at the first point, I'm going to measure to C. Swing that to the other side of my line, right, reflect it over. And then I'm going to do the same thing from B at that point. Swing that to the other side of the line and reflect it. Now I'm going to switch my compass around so it is facing from the other direction, from that other endpoint, and repeat the process. A is not going to move, so I'm not going to measure to A, but I'm going to measure to B and to C and just see where those intersection points are. So there is where C is. So spin that around to the other side, reflect it over, and that will be C prime. And then do the same for B, reflect that over, and that will give me B prime. And then A and A prime are the same point, so start at A, and that will be B prime, and this will be C prime, and connect it back, and then make sure you label your points. Next, we're going to look at determining the line of reflection, and the line of reflection should look something like this. It should go between 2 of my points and be right in the center. So I'm going to connect a pre-image point to an image point, and then I'm going to bisect that, because remember, the line of reflection is the perpendicular bisector of the line connecting the pre-image and the image. So we're going to put our compass on one endpoint, make sure it's open more than halfway, repeat the process, and then we are going to connect those. Now I need to make sure that those are actually intersecting, and then this will be our line of reflection. Use your straight edge to connect those. The next is constructing a rotation, and this tends to be the one that's the most challenging for people. So I'm going to start with a 180-degree rotation. I'm going to first draw a line that connects C to my center of rotation, and I know I want to rotate this 180 degrees. So that's from A to C, and if this rotated 180 degrees, it would rotate exactly around to the other side of this line. So I'm going to rotate my compass there, and that would be where C prime is. So that point right there, that intersection is C prime. Now I can do the same thing for B. I'm going to connect that to my center, and I want to rotate point B around 180 degrees. So I'm going to put my compass on my center point, measure from A to B, and then rotate that around 180 degrees. And that's going to give me where B prime would go. So that's point B prime, where those two intersect. So labeling that B prime, I know that that is my image. And to find my image of the segment, I can just connect B prime to C prime, and that would be what it looked like rotated around 180 degrees. The concept is very similar with 90 or any other angle. I have videos on all of these separately, so I'll link those down below. But these are not something I would spend a ton of time studying. I think you should get the big ideas. So if I want to rotate 90 degrees, I'm going to start by constructing a 90-degree angle. So I'm going to bisect a segment to do that. So I'm going to put my compass at the center of rotation, create a segment around that center, and then bisect it. So this is the perpendicular from a point on the line construction. And by doing that, I wind up with a perpendicular line that goes through the center. So I can see here that that is at a 90-degree angle to the angle that connects A and D. Now what I really need to know is, well, how far out on that line would D be? Because I know it gets rotated 90 degrees, but I don't know where exactly on the line it would be. So I'm going to measure from A to D using my compass. And then I'm going to rotate that 90 degrees counterclockwise onto my line. And that is going to be the point D prime. And you would just repeat that for your other segments. Now I will tell you, again, if you want to see other videos on this, check in the bar down below, but we are going to move on to some more constructions. The next thing we're going to try to do is find the center of rotation. And we're going to use two perp bisectors to do this. So knowing that we can always find the center of something, or of a circle here, if we bisect two chords, I'm going to do that here. So I'm actually going to look at the second one. I'm going to connect any two corresponding points. So here I'm going to connect D and D prime, and I'm going to bisect that segment. So put my compass on one endpoint, open it more than halfway, and get the perpendicular bisector of that. We've done that a few times today already. And use your straight edge to draw in that bisector. And I would extend it out pretty far. You are never sure where these are going to intersect. Now I'm going to change colors here. I'm going to connect B to B prime. And it could be any other 2 points. I just chose those. And I'm going to take my compass, put it on one endpoint, and then I'm going to bisect that. So again, open it more than halfway. I'm going to change the color here so that these match. And there's one arc. And now let's draw the other. Be thankful you're not using a smartboard compass on the Regents. So here's my perpendicular bisector of BB prime. Where those two intersect is my center of rotation. And remember, these can get messy, but that point right there that I'm circling where those two intersect is the center of rotation. And this is it. This is our last construction for rigid motions. We're going to be translating along a vector. So first I'm going to measure the vector, and I'm going to draw an arc from each pre-image point that distance, because that tells me how far it will be moving. Then I need to see how far away they are from the original pre-image point. That's my reference. So from A to B, I'm going to measure, and then I'm going to slide it down and say, well, that's how far away A prime and B prime should be. And from A to C, I'm going to measure, and that should also be how far away A prime and C prime are. So A to C is this long, and A prime to C prime should also be that long. And now I'm going to just connect those. So use your straight edge, connect A prime to B prime to C prime, and make sure that your points are all labeled correctly. So B should correspond with B prime, C should correspond with C prime, and let me make sure these get dragged into the right spot. So C prime should be down here, B prime should be up there. Awesome. Let's do one more of these. So this one, they didn't give me the vector on this next one. There we go. So I'm going to draw it in. So I see there's B and there's B prime. So first thing I'm going to do is construct that vector. And now it's exactly the same construction. So I'm going to measure the vector. And I'm going to translate each point that distance. So I'm going to slide that to point C and translate it, and then slide that to point A and translate it. And so each of those are the same distance away as the vector. And then I'm going to measure from B to C. And I'm going to determine that that is the same distance from B prime to C prime. So slide that down, make those intersect. Then I'm going to measure from B to A. And I know that that should be the same as going from B prime to A prime. So slide that down, and that will be the same. And then you can connect your points. So use your straight edge, connect B prime to A prime to C prime, and that will be your center, or I'm sorry, your translated image. Make sure they're labeled. Here's our very last construction. We're going to dilate here by a scale factor of 2. So the first thing I'm going to do here is I'm going to put in my sort of guidelines, my projection lines. Those are the lines along which the dilation moves. And then knowing that it's a dilation by a scale factor of 2, I know my shape is not only going to get 2 times bigger, but it would also get 2 times further away from the center here, which is A. So I'm going to measure from A to my first point, which was Y, and then I'm going to double that distance. So I'm sliding from my center being at A, sliding that point up to Y, so that point is twice as far away. I'm going to repeat this for X. Again, be thankful you are not using this compass on the Regents. We need to measure from A to X, so I'm going to slide that down so I get that measured. And then we're going to double that distance. So now take your compass, slide it up to X, and double the distance you are away from A. And then repeat that one last time for Z. So I'm going to measure from A to Z. That would be my distance from the center to my pre-image point. I am then going to double that distance, which would be that. And that would be the location of Z primes. Remembering those have to stay along the projections. So now I can connect those 3 points. Those are my image points, Y prime, X prime, and Z prime. And that is not only double the size, but it is also twice as far away from the center. And I know that the lines also stay parallel because it's a dilation.